Hey everyone. In today's lesson, we're going to take a look at how to check if a coordinate point is a solution to a linear inequality. So looking at it algebraically first, we're given a point here, 2, -1, and we're checking to see if it is a solution. You do this just like you would with a regular equation. Whatever you end up at the end, if it's a true statement, it's a solution. If it's not a solution. Okay, so here we have our x and our y. That's going to be our 2 and -1, and that's what I'm going to plug into this inequality here. Okay, so we have a -1 in for y less than or equal to -3 times 2 minus 4. -1 less than or equal to, that's -6 minus 4, and then I have -1 less than or equal to -10. Now here you ask yourself, is -1 less than or equal to -10? No, it's not, right? -1 is greater than -10, so that means that this is not a solution. Okay, sometimes it helps to read it out loud to yourself. Okay, let's take a look at a couple of more examples. Okay, here we have two more. Again, we have an x and a y with each of these. Okay, so we have y, which is 2, is greater than 3 times 1 minus 1. Okay, so that's 2 is greater than 3 minus 1. 2 is greater than 2. Okay, well, is 2 greater than 2? No, it's not, right? So this one would not be a solution. Side note here, the one way that this could have been a solution is if we had gotten, say, 2 is greater than or equal to 2. Now, if we had gotten something like this, we see that it has the equal to sign, which makes this one actually a solution because 2 isn't greater than 2, but it is equal to. So this one is greater than or equal to. That would technically be a solution. Just a side note to know there. But again, this one here, not a solution because it does not have the equal to. Okay, let's look at the next one. All right, so again, we have 3 greater than or equal to 4 times -2 minus 3 is 3 greater than or equal to, that's -8, which gives us -11 when we do that. Is 3 greater than or equal to -11? Yes, it is. Okay, so this is a solution. Okay, so again, what you're doing here is plugging in your x and y, and you are checking to see if what you end up with is a true statement or not. If it's a true statement like we see here, it's a solution. If it's not a true statement like we see here, it is not a solution. Okay, let's take a quick look at this graphically as well. Pretty straightforward for seeing if it's a solution graphically. Pretty much if it falls inside our solution set or our shaded region in the graph, that's going to be able to tell us whether it's a solution or not. If it's in the shaded region, it's a solution. If it's not, then it is not a solution. Okay, so let's go ahead and look at these points here. Okay, this is a graph of our inequality. Notice how it's shaded on one side. That represents all possible solutions to the linear inequality. Okay, so let's go ahead and graph these and see if they are solutions. Okay, so I have 1, -2. 1, -2 is this point right here. Okay, I have 4, -3. I'll label that A. I have 4, -3, which is right here. That's B. And then I have 0, -4, which we'll label as C. Okay, so let's take a look at these a little closer. Okay, so if we see here our point A, 1, -2, that one falls inside of our shaded region, so that one is a solution. Okay, 4, -3, clearly outside of our shaded region, so this one is not a solution. Okay, and 0, -4. Now this one not technically in our shaded region, but it is part of our line. Now because our line is solid, that means it's included as our solution, so this one would be a solution. If that was a dashed line and our 0, -4 fell on it and it was a dashed line, so if it was dashed, that would actually not be a solution. Because again, when it is a solid line, that means that the line is included in our solution set. If it is dashed, that is not included in our solution set. All right, so that's pretty much what you need to know for checking your solutions to linear inequalities.